So the problem with this approach is that not all intelligent behavior can be broken down into logical steps. For example, in politics or warfare, we don't have a well-defined set of rules. For example, like in playing chess or doing mathematics. So to fill the void, essentially we had to introduce the theory of probability, which allows rigorous reasoning with uncertain information. So this allows us to still maintain the rigor required for logical thinking, but while allowing for randomness and uncertainty. So the theory of probability then allows the construction of a comprehensive model of rational thought, leading from raw perceptual information to an understanding of how the world works to predictions even about the future. Now, the last definition of intelligence then is the ability of a machine to not just think rationally, but to actually act rationally. Okay, which is this approach or this definition is known as the rational agent approach. So you probably heard the word agent in multiple contexts recently because of the development in large language models and other AI tools. So an agent in general is just something that acts. Okay. So of course all computer programs do something, but computer agents are expected to do more. They're expected to operate autonomously, perceive their environment, persist over a prolonged time period, adapt to change, and create and pursue goals. So a rational agent then is defined as one that acts in a way to achieve the best outcome, or when there is uncertainty or randomness, the best expected outcome. Okay. So this essentially concludes the four different definitions of intelligence. And the rational agent approach to AI in particular has two advantages over the other approaches we discussed earlier. First, it's more than the laws of thought approach because correct inference is just one of several possible mechanisms to achieving rationality. Second, it's more suitable for scientific development. The standard of rationality is mathematically well defined and completely general. So we can often work back from this specification to derive agent designs that will complete whatever objective we're trying to maximize. So for these reasons, the rational agent approach to AI has been the prevalent approach through most of the history of artificial intelligence. So in the early days, rational agents were built on logical foundations and formed definite plans to achieve specific goals. Later, when we introduced probability theory and machine learning, we were able to create agents that could make decisions under uncertainty and maximize the probability of reaching a specific outcome. So essentially, we can say that AI has focused on the study and construction of agents that do the right thing. So that's our approach, and the best conclusion based on all of this is that our goal here is to develop an agent that can do the right thing. And defining what is the right thing requires what we call defining an objective function, as you will see. For example, in operation research, this objective function is a policy that maximizes the sum of rewards. In statistics, the goal is to minimize a specific loss function. In economics, for example, decision makers try to maximize utility or some other measure of welfare. So there's always a well-defined objective for our agent, and that's the approach we're going to be using here, is to develop an agent that can act in a way to maximize or minimize the objective function, whatever we need to be done. So let's look now at the history of AI and the fields that contributed to the foundation of AI. So the very first ideas of artificial intelligence came from the field of philosophy. Okay, asking questions like, for example, can formal rules be used to draw valid conclusions, which we discussed earlier as logical thinking. Another question that was studied is, how does the mind arise from a physical brain? Where does knowledge come from? How does knowledge lead to action? So these are all questions that were addressed in philosophy by, Aristotle, for example, was the first to formulate a precise set of laws governing the rational part of the mind. He developed a specific system for proper reasoning, which in principle allowed one to generate conclusions mechanically given initial premises. Again, other contributors include, for example, Leonardo da Vinci in the 1500s, where he designed but never built a mechanical calculator. Okay. The first known calculating machine was constructed around 1623 by German scientists. So these are all early developments that contributed to the definition of what is knowledge and how we can think or reason in a structured way. Next, the field of mathematics. Some questions that were studied here. What are the formal rules required to draw valid conclusions? What can be computed? How do we reason with uncertain information? So philosophers then set some of the fundamental ideas of AI, but the leap to formal science required mathematization of logic and probability. So taking the ideas of philosophers and setting mathematical rules for logic and probability, and the introduction of a new branch in mathematics called computation. Again, the idea of formal logic can be traced back to ancient Greece, India, and China, but the mathematical development really started in the 1800s with Boolean logic, George Boole, and later scientists extended Boolean logic to include objects and relations. creating what's known as the first order logic that is in use today. The theory of probability can also be seen as generalizing the logic to situations with incomplete or uncertain information, which is very important for AI. So, some significant development here include, work by Blaise Pascal, which essentially showed how to predict the future of an unfinished gambling game and calculate average payoffs to the gamblers. With essentially, probability quickly became an essential part of quantitative science because it helped deal with uncertain measurements and incomplete theories. Okay, some major contributors include Bernoulli, Pierre Laplace, and others who advanced the theory of probability and statistical methods. Now, another field that contributed to the development after that was economics, asking questions like, how should we make decisions in accordance with our preferences? Or how should we do this when others may not go along? Or how should we do this when the payoff may be far into the future? So, the science of economics originated in the 1700s with Adam Smith proposing to analyze economies as consistent of many individual agents, each of them focused on maximizing their own interests. So while most people think of economics as being about money, in reality, the very first mathematical analysis of decision under uncertainties and the maximum expected value formulas were all developed in economics. Another field that also contributed a lot is neuroscience, obviously, specifically answering the question, how do brains process information? So neuroscience essentially is the study of the nervous system, particularly the brain. So although the exact way in which the brain does the thinking is still not known, still the study of the brain has enabled us to mimic some of the actions that happen in the brain, as you will see later on with neural networks and other models. So we will actually borrow a lot of the terminology, for example, nerve cells and neurons, and we're going to try to use the same approach in defining our information flow, similar to signal that are propagated from neuron to neuron in the brain, of course using electrochemical reactions in the brain, but for us it's going to be using mathematics. Okay, we'll continue in the next part.